existential risk or like an existential catastrophe is something where afterwards the expected value of the universe, or debatable what they can actually count that, if that is much lower than before the event, then existential hope or eucatastrophe, which is the opposite of a catastrophe, which would be an event after which the expected value of the universe would be much higher than before. And so I think Toby Ord and Omar Barrett, when they laid out this concept, they were pretty ambitious. Like, I think for them, an example of a eucatastrophe was actually the kind of like the genesis of life. So that's a really big one, right? Like that's a kind of like hard goal to meet as a positive scenario, but we can, potentially like think about others. And I think thinking about these like positive scenarios for the long-term future or even the near-term future of humanity is pretty undervalued.
Welcome to the What the Biohack podcast, powered by Bronic, to discover what the heck security means for biology. We interview some of the world's mad scientists and rad hackers across deceivingly unrelated disciplines to uncover what the future holds and how we can design against crime. My name is Dr. Miriam El-Gabri, your host, and today we're speaking with Allison Duettmann, who is the president and CEO of Foresight Institute, which does so many things, and we're going to get to what all these things are. Intelligent cooperation, molecular machines, biotech, health innovation, tech trees. I mean, this is just literally scratching the surface. So I'm really stoked to have Allison here with us today. She focuses on AI safety and so much more. In my mind, she's a greatest thinker. So welcome, Allison.
Thanks. Yeah, it's really, really nice to be here. I'm neither a mad scientist nor a hacker, but I do like to work with them. And so I hope that I can talk a little bit from the sidelines about
You have a
what
talent
I see
in bringing them out, putting them together, and making them do stuff. So I think, I think it's like an honorary badge, to be honest. So let's start.
Yeah, I take it.
Let's start. Do you want to talk to us a little bit? Just give us a brief about the Foresight Institute, and then we can kind of get into the nitty-gritty and actually talk about all the really cool things that you guys do.
Yeah, sure. So Foresight Institute, actually, like I didn't found it. It basically existed before I existed, since 1986, 1987, depends how you count. And I think since really before I was born, it was this really, I think in my mind, magical place where people came together and really kind of like worked on positive technologies, but from a scientific lens, but like nevertheless with a pretty like big eye for the future. And it kind of got started on this book, Engines of Creation, which was a book about mostly molecular nanotechnology, but from the early days, it always had this like relatively wide-ranging interest of not just molecular nanotechnology, but many of the applications that that technology can bring in tandem with AI. So molecular nanotechnology was seen as the engines of creation, while AI was seen as the engines of design. And from that, Eric Drexler, our co-founder, kind of like saw this kind of like really ambitious world of applications for longevity in healthcare, but also for space development. And so he kind of walked through kind of like the positive scenarios, but also potential risks in this world. And so many of the technologies that we now focus on, which includes molecular nanotechnology, biotechnology, neurotechnology, space, and AI, they were already kind of like implicit in this book, but never really like that they were like one of our core focus areas. And over the years, we kind of like really rolled out different programs on all of these different technological tracks and to really focus on them kind of like more explicitly. And so that's, I guess, what we've been doing for the last, I guess, 8 years or something since I've been with Foresight. And yeah, I can speak more to any of them in more detail, but that was kind of like the quick genesis of how we got to where we are today.
How did you end up at Foresight? If you're happy kind of sharing your personal journey or path towards it.
Yeah, well, I just basically cold emailed Foresight. So I was, I think, doing my master's thesis on AI safety back then, and I was strolling the internet basically and was looking for other organizations out there that are thinking quite ambitiously about the long-term future, but from a relatively sober, sane technological lens. And Foresight kind of like just immediately popped into my view. Back then, we still had our old website, which also meant we had tons of our old archives out there of like previous gatherings called Vision Weekends, and we can talk a bit more about like what they turned into. But basically, people were meeting since our inception in 1986, multiple times a year, really across different technologies to like actually figure out how we can move them forward in a positive lens. And back then, they already had like such an ambitious view for the future, and that was deeply inspiring to me because mostly when I looked on the internet and finding something about long-term futures, which I was very interested in, you either had, I think, pretty philosophical texts out there, very philosophical transhumanist text or something, but very little action potential behind it, or you had, really scientific texts or like scientific resources about what we can do today. But you never had really that intersection between people that come from a scientific lens about where we are today, but where we could be going in a positive way. Much of the, I think, resources that I found were also pretty risk focused, and pretty like worried about the future even back then, I think. And so this kind of like optimism for the future paired with kind of like a deep, kind of like scientific groundedness was really inspiring to me. And I literally cold emailed them, uh, and I asked how I can help, and then they basically asked me just to come over. And at that time, I didn't know that that meant coming from London to the Bay Area, but I then did. And since then, I've not really left. Well, of course, I'm leaving every once in a while, but since then, I've been kind of in San Francisco very happily. So it was kind of very coincidental. And I do always think that, cold emails do work, especially in the Bay Area. If you kind of like are actually like honestly interested in the subject, I think people actually do take that time of day. I certainly do. When people cold email me, if I think that there's actually something interesting to explore here, I would definitely go for that. So I
Yeah,
think
I
it's useful.
absolutely love that. Yeah, it's kind of, what's it called? Take your like, make your own chances, basically. Don't wait around and actually make it happen. You touched upon a lot of things that I'm kind of like, it's this dyslexic or ADHD thing that I wanna cover all of them all at once, and it's not possible. So I'm just gonna, just tackle the first one, which I'm mostly excited about. So you spoke about AI safety, and generally when we talk about, I mean, any kind of emerging technology, but it is kind of hot topic AI currently. We do tend to look at it from this perspective, as you very well mentioned, from an existential kind of risk point of view, and dare I say, sometimes it's like kind of an alarmist viewpoint. Um, what I want you to do is, first of all, tackle those three things that I've said, but the main focus is to really talk about something that I really, when hearing about Foresight Institute and then looking you up as well, I was like really interested in the thing that you did find, which is this concept of existential hope. And I've watched your TED Talk, and of course, all these links we're going to put in the podcast for listeners to kind of go and have a look and have a listen. Which certainly during my personal time, and I was doing my PhD at, again, identifying emerging threats. So it's a very kind of almost negative or pessimistic view on emerging technology, or at least you have to get into that viewpoint to then, in my case, it was to design against that. But it was really, nevertheless, it was really tiring because you have to go through the literature, you have to like read all about this, and it is quite from a risk viewpoint. And then when I came across kind of your talk and how you speak about these same topics, really was refreshing. So, without further ado, please can you walk us through, for the listeners that kind of don't know these three things? Can you walk us through it, and please end on the positive note because that's the gist.
Yeah, again, I didn't actually found this concept. It's again from someone else, Toby Ord and Owen Cotton Barrett. They published a paper on existential hope. It was fairly short at the time, a few years ago now, and it kind of like was another kind of like shift in my worldview, or like not really shift, but like more of where I felt suddenly very at home or seen, in the sense that, you know, at least I'm like Foresight is pretty adjacent to, or like works a lot with the existential risk community as well. Um, because I think many of the technologies that we're focused on, including let's say biotechnology, neurotechnology, molecular nanotechnology, AI in space, in most of our technical tracks, we often focus on like the positive outcomes of these technologies, like basically like advancing these technologies for the benefit of life. And we have fellowships in this, we have grants in this, we have prizes in this, those seminars and workshops. And sometimes it can seem a little bit Pollyannish of just like advancing these technologies into like nowhere land. And I think that from the get-go, we always wanted to have this like deep sense of kind of responsibility from a scientific lens of like really making people aware that they're building technologies into a certain direction, and having this almost, I think it's a term in the also existential risk community, differential technology development approach to it, which means that oftentimes there are technologies on a specific track that you can advance before, that are perhaps more safety or security enhancing than other technologies that you could also be working on at the same time. So I always think, for example, computer security, especially when you think about AI progress, is something that in the computing area we should really be focusing on, because if we don't have solid computer security before we have very advanced artificial intelligence, I think things will go pretty sideways. But that's just one example. But I think we're always thinking in terms of this DTD framework, but that's nevertheless, like kind of like incremental. And I think when I stumbled across this existential hope paper, it was really inspiring because they really kind of flip the term existential risk, or even like the concept of existential angst, which is perhaps a little bit more visceral to some of us. They flip that on its head and think about, well, what if we thought about like the opposite of a very, very bad scenario? If like an existential risk or like an existential catastrophe is something where afterwards the expected value of the universe, or it's debatable whether you can actually count that, if that is much lower than before the event, then existential hope or eucatastrophe, which is the opposite of a catastrophe, which would be an event after which the expected value of the universe would be much higher than before. And so I think Toby Ord and Omar Barrett, when they laid out this concept, they were pretty ambitious. Like, I think for them, an example of a eucatastrophe was actually the kind of like the genesis of life. So that's a really big one, right? Like
Yeah.
that's a kind of like hard goal to meet as a positive scenario, but we can, potentially like think about others. And I think thinking about these like positive scenarios for the long-term future or even the near-term future of humanity is pretty undervalued. And I know that, like, for example, Creon Levitt, who's like a dear collaborator and who's leading our space tech track, he basically, I think, summarized it really well the other day. He basically said, well, if we only ever focus on running away from specific things, on trying to avoid specific things, that never means that we will arrive somewhere, because you can run away from something and like kind of like all these different directions, right? But that doesn't mean that you actually get to where you're going. May just be running into a totally different direction that is very much not on the path that you want to go anyway. So I think just focusing on what we don't want never really actually means that we'll ever get anywhere where we do want to go. And I think that there's a few specific concepts that are kind of at odds with each other when you think about this. So, for example, there's one kind of like concept called MaxiPOC, maximizing the probability of an okay outcome. And I think it's from Bostrom. And he basically says that, well, we should really just be striving to like not die as a civilization, because not dying already means that we're probably going to have a pretty good future, because over time, if you look back at our civilization, we've been making relatively steady progress for most people on this earth. And even though that's slow, nevertheless, things are getting better. So as long as we don't die and don't kind of like kill ourselves, we're going to end up in a pretty good world. Arguably, we already are. And this is kind of this notion of almost a protopia, that we're like gradually making progress and we should just carry on. And I think that's kind of true. And that's a little bit at odds of like actually aiming for like very, very positive worlds. But I think even if you think that we should really just aim for not dying, I think it's still nevertheless sometimes good to kind of like scenario build and like world build and plan for positive worlds, because I think that inspires a bit more of a cooperative nature across different people, rather than just focusing on like kind of zero sum dynamics and like things where we just want to avoid kind of like really bad defective outcomes amongst ourselves. If we actually like kind of raised our gazes a little bit and actually focus on like where we do want to go, I think that could allow people to be a little bit more cooperative in a way that just focusing on where we don't want to go perhaps doesn't allow. So I think even if you think that we just want to kind of get by, I think it's still useful to have a carrot that people can cooperate towards, rather than just avoiding like the worst case outcomes. So that's a lot of kind of like mumbo jumbo, but I think there's just a lot of different concepts to unpack, and like many new concepts are currently being developed in that realm. But I think it is currently undervalued to think about positive worlds, I think, generally in our media, but also like in the very technical community, we focus a lot about on risks. And I don't mean to go all techno optimistic here, but like I do think that we don't really think bright enough, often at least. And I think it would be useful to change that.
Yeah, I think I agree with you there, Allison, and I think it's that sometimes when we do think about technology, we get worried and okay, I don't even wanna comment about the media thing because it's always that, fear sells, and I think that's where it kinda stops. It's one of those, like, basic human behaviors that's just tapped on, and that's like a whole podcast on its own. But I think at least with technology, we kind of yeah, we play off of that, fear, and it's almost as if we don't take that one step further, which is, "Okay, this is the direction we wanna go. This is where technology is going. These are the kind of risks or the things that we're, identifying as, potential issues or challenges." But we don't take that one step further to kind of, as you say, optimistically and creatively design around that or with that or to prevent that. And I just wonder whether I think what was it that you said, Maxi-Pop is a little on the other side of the spectrum. I think it doesn't allow you to go that one step further to actually, tackle both, like, the risk aspect, but kind of wrap it into the hope and better scenario, towards a brighter, future. You mentioned another thing that I also got really excited, about, which is this concept of cooperation. But honestly, I think Foresight Institute like really takes it to like a literal meaning in terms of diversity of perspectives and individuals that you kind of seek out and put together, whether that be in a physical kind of room, or should I say chateau in some cases, um, and or even online. And I think it's really a testament to a lot of you know these things that we try and say in other arenas like academia or even industry, that we need more diverse kind of cooperation and more, I mean, can I say a little, I don't want to say radical thinking, but a little like out of the box thinking and this like crossover. And again, I'm going to stop babbling and like, honestly, I want to hear from you. Like, how do you achieve that? And talk us through like all the projects like the tech trees, and talk to us about the events that you do, especially Vision Weekend, which by the way, is just incredible for people that haven't been. And we're definitely gonna deep dive on, like, unusual experiences and memorable moments there.
Yeah, I mean, I think, from the early inception of Foresight based on the engines of creation, I think that book was already so multidisciplinary, like it really spans so many different technological aspects. And I think, you know, since then we've really honed in on that in the sense that, we have these different technological tracks that I just mentioned. And in each of these tracks, we have like a fully blown program, including fellowships, prizes, including workshops and seminars. And so each of these tracks is kind of like this its own little technological arm of Foresight, of this octopus of Foresight. But we also really kind of like focus on a lot of interdisciplinary collaboration among across these different tracks. So I think oftentimes I get asked like, well, why don't you just focus on AI, or why don't you just focus on nanotechnology? And I'm like, well, the problem is that no one focuses at the intersection of these. So I think our niche kind of is that we don't have one niche, but that we mostly focus on kind of like the kind of like connecting glue between these different tracks. And I think that people always say that they want interdisciplinary collaboration, but then actually in practice, people really don't go for that. And I think that comes from many different kind of like more kind of like meta traps of like including, potentially it being uncomfortable for you as like a technical person in one area to kind of like get your feet wet in another area. It's kind of like uncomfortable to be the noob in a different area. But it also comes from the fact that often funding is pretty like kind of like directed to one specific problem in one specific domain, and there is just not really an incentive for researchers to kind of go out and like kind of take others by the hand and collaborate across different, let's say, departments or universities or even like sectors, like and I think without that incentive to collaborate interdisciplinary, we won't really get there. And so I think it starts pretty much at the funding, but what we're hoping to do is a little bit like creating this third space where people can get together and in a relatively safe and relatively like forgiving container really think about the implications of the technology that they're working on for another field, but also kind of like explore what other fields may mean for their technological development. Because I think oftentimes progress happens at the intersection of fields, right? The interesting one, the really groundbreaking one, because that's where people are not really looking enough. And I think that, across history, really, I think oftentimes these fields are almost like artificial constraint on like a much wider problem space. And once you have someone that actually can explain to you what that other space means, you can get a lot done in a few days. And so we usually have these technical workshops that really bring people from like a few adjacent fields that don't really talk together to kind of make progress on one problem in just 2 days. So, for example, last year we had one workshop on whole brain emulation and brain computer interfaces for AI safety. And so, kind of like the idea here was that often for AI safety, we're focusing on like making the system safe, but is there also an approach where we could really focus on like upgrading human intelligence and human based like software intelligence? Because it would allow us to potentially can like be more competitive with AI systems, but also because we already know a little bit better, at least, how to align other humans with humans than to align AI systems with humans. And so I think the idea here really was to kind of figure out if we can learn a little bit from progress in whole brain emulations and brain computer interfaces also for AI safety. And these fields don't often very much talk. I mean, these fields are both very, very new themselves, right? There aren't that many people working in these areas if you think globally. And so bringing them both together and seeing if there's a there at that intersection, that was interesting. And the same, we often do for longevity and AI, for example, but also for molecular nanotechnology and simulation software. So it kind of holds across fields here. But yeah, it's a difficult container to build. But I think these workshops are usually, I think, where they're at least my favorite parts of our program is really these in-person workshops where people get 2 days to connect deeply across different technological areas, usually using Chatham House rules across the day so that you can really call each other out if there's a mistake there. But usually there's projects that come out of this that are absolutely amazing. They always boggle my mind. And so I think we can make a lot of progress at that intersection. And it would be nicer if more people were looking there or supporting it more with actually like larger bucks than we can currently support.
What was the outcome of the whole BCI and AI workshop? Anything interesting that came out, or any work that's kind of being continued now?
Yeah. So first of all, when we like when we were thinking about holding the workshop, it is a pretty strange topic. Or like it's for most people, it's like, it's two really weird things combined in one workshop, and they kind of just think like this is a sci-fi problem. I'm out. But so we thought we wouldn't be getting very many yeses for our workshop or that many kind of like confirmed participants in the beginning. But then the opposite happened, and at the end we ended up with a wait list that was longer than the actual workshop. So the wait list for attending the workshop was exactly as long as the list of participants at the workshop. So we had like a little bit over, even like double the amount of people that want to come that then could make it. And so I think that was the first kind of surprising thing that happened, that there's actually a lot of people that were thinking about it, I think pretty under the radar, or at least not in a coordinated fashion with each other, or at least not as far as we know. If you're out there, then please contact us. We love to help out. But that was the first thing. And then I think the second thing was, we co-hosted the workshop with Anders Sandberg from Future of Humanity Institute, and he wrote co-authored the first whole brain emulation roadmap back in, oh God, I think it was 2007 with Nick Bostrom. And so it's been a really long time since people actually were developing or like actually looked at the space from a bird's eye view. And so it was already time to kind of update that roadmap in general, because so many years have passed since then, and a lot of technologies have occurred since then that weren't even in the roadmap. And so it was always kind of like a dream of ours to do a workshop on this roadmap in general and just kind of like update it. But then with AI kind of like becoming a little bit more of and like at the forefront of people's minds, and over the last kind of like 5 years, we really thought about that intersection much more. And so bringing people together at that intersection became a little bit more urgent right now.
Mhm.
And so that's how kind of like the workshop came about. And so one thing that came out of it is now that we funded a project that is actually revamping the original Hope Animation roadmap um, with a lens for AI safety. So if you're particularly worried about AI timelines, which kind of like whole brain emulation or even DCI technologies could you differentially speed up to make some progress on safety for AI? So that's one bit that came out of it, and that roadmap is currently kind of like being under construction. And hopefully at our next whole brain emulation workshop, which will happen in May 2024, at this time in a venue that can hold double as many people, oh no, I think even more. I think three times as many. But we're hoping to actually review that roadmap that came out of the workshop and soft launch it there. So that was one project. But since then, lots of different people have been working on individual projects, and we have kind of since then launched an entire program, like an AI safety grant program, to actually fund many of the kind of like projects that came out of that workshop, but also many kind of like projects that have occurred since then, unrelated to the workshop. And so since then, we finally have like a funding arm that can actually support different kind of like project development in that space. And for that AI safety grant program, whole brain emulation is just one topic. There's like two others as well, which we can also dive into. But since then we've been kind of like focusing on that a little bit more. And I already know of like two other projects that have occurred where there was some rough coordination around at the workshop that are currently really gearing up on like a kind of like low-fi approach to whole brain emulation, which is AI safety relevant. And so I'm not sure if I can talk about them publicly yet, but I think at the time of the next workshop, they should be pretty much out of stealth. And so there should be a little bit more kind of like interesting, more public development coming out of the pipeline.
Yeah, I was gonna kind of prod, and I'm gonna ask if there are any specifics, but stuff will come into kind of public view around May next year, is my understanding. Okay, and the other two topics which I've noted, that was neurotech, and then there was multipolar AI scenarios, which I think you're gonna have to explain. And then just like general security, if I'm not mistaken, were the kind of three broad topics. And once you kind of explain especially the multipolar one, maybe provide some insights in case there are some people that are interested in kind of going for the AI safety grant, if there are any specific projects or research areas within these categories that you find particularly promising.
Yeah, so the grant program I think was started a few months ago now, and it focuses on like three areas within AI safety that we think of as relatively underexplored compared to other AI safety domains. So it doesn't mean at all that we don't think the others are important. It really just means that we want to focus our funding where we think we have a comparative advantage in reaching out to a community that is already working on this, but also B, where we think in general it's like still pretty undervalued, or like at least we want to focus on resources there to explore it. And one of them I already mentioned, the neuro specific AI safety track, but the other one, the multipolar AI one, is basically like built on this kind of like at least hypothesis that, or at least like a hunch, if you want to call it, perhaps a bit less technical than a hypothesis. But it's basically built on this idea that there may be scenarios in which you don't have one AI system or one artificial general intelligence system that is very powerful, but where you have many, and not just two, but three or like six or more, and ideally like as many as possible artificial intelligences that are pretty specialized in a specific domain, but that nevertheless can cooperate in a secure manner across each other and with humans. And I think that was always like a big kind of like focus area that we thought was underexplored, because I think currently what you see is a lot of different technological tools kind of coming online. Of course, you have a few kind of like major AI labs that really focus on like a few that it's somewhat centralized, I think, the AI development. And so you could think maybe the final agent that pops out of this is also relatively centralized. But I think on the other hand, you also see a lot of kind of like individual actors kind of like coming on stage that focus on specific use cases of AI. And there was this interesting, very long paper from Eric Drexler that really focused on kind of like a scenario where you kind of have super intelligence across civilization, but rather than having one actor or like one very advanced artificial intelligence system that kind of like rules or dominates the world, it is actually like a web of many different AI systems that are specialized in individual problems, and that are kind of weaved into this kind of like secure cooperation framework. And so that's, I think, where a lot of the security aspects and cryptography aspects, which is the third part of our grant program, comes also into place, because I think we kind of like are really underestimating, I think, the impact that security and cryptography technologies can have on AI and AI safety. Once, because I think many of the computer security structures, or like the infrastructure that AI systems are being built on right now, is just not secure. And so I think that is already a problem, even if you just took AI out of the picture. But then when you actually think about AI, I think it really becomes a problem. A, because it may be much better at exploring potential vulnerabilities, but also B, because AI systems, take a lot of GPU to train, but then once they're trained, they don't take a lot of GPU to run, which means they are a pretty like attractive target for potential attackers, kind of like stealing the actual original models or model weights and so forth. So I think they're just a very juicy target that we haven't really learned to secure very well yet. And so I think security for that is already undervalued. But then the cryptography part of the third kind of grant bucket comes in, where we often think about kind of cooperation structures across humans, and we often use law for that, or like legal structures, and we sometimes use like other tools for that, including like norms and so forth. But with kind of like cryptographic tools and auxiliary techniques, I should always point that out. It's not just cryptography, but it's like also secure multi-party computation and like other just computing techniques. We can often create an ecosystem in which different entities, humans and AIs, can actually cooperate securely. And so many of the things that we currently do, like with law, or that we currently do, that are like pretty just like unsecure and like almost unpredictable. Like we could basically by exploring many of the cryptographic techniques that are currently still in the research areas, such as federated learning, homomorphic encryption, differential privacy, secure multi-party computation, like many of these kind of like bits and pieces that are still pretty researchy. If we actually use these tools much more, we could create a really rich cooperation kind of like structure, or cooperation architecture between humans and AIs, or even between humans verifying other AI systems, that is privacy preserving, that is relatively secure, and that is relatively flexible. So where you can still have kind of like relatively ambitious technological development, while also kind of potentially proving that it's safe. And so there's many different projects under that umbrella term. It's a very, very broad field, but I think it is already not getting as much love as it should be, just for as a field itself. Cryptography is like pretty underfunded, I think, in general, and it's very underexplored, I think, for AI in particular. So I'd be excited to see more projects in that space.
Yeah, I'm not sure why security isn't sexy yet. I'm serious. I've been like, and it's just my career in the field is like this much in terms of like how long it's been existing and continue to existing, but it's not sexy enough. It's just not on a front page of a newspaper. I am actually a little mind blown on the multipolar. I don't think I personally have heard, like, I haven't even thought about the perspective. I think a lot of discussions are quite centralized on like super AI being this like singular thing. And I like the concept of how did you call it? Was it like a security web or a network of security kind of AIs or like agents within? Um and it I like it because it kind of reflects the way that we function, right, as humans. And why would we think about it any differently if anyway the way that AI, or at least as it currently works, is a reflection of all of our data, right? Um, but I want, because some of our listeners are like, some are quite techy and they'll be already researching the stuff that we're talking about, but others like are kind of really just getting introduced in all of these concepts. And so can you really, really break it down, this like security network of like interaction between AIs and humans and the verification? Is it something that like we'd have like a 2FA to understand, like to prove that who we're talking to is an AI or human, or what does that look like practically for someone that doesn't kind of have deep tech uh, understanding, and maybe bring it to the actual consumer that's actually getting really excited by things like chatbots as what it means for AI, right? Their previous interaction hasn't been anything other than the chatbot and kind of increasing their productivity with email writing. as one application that I'm guessing people are using ChatGPT for.
Yeah, for sure. So I think, well, there's a lot to say on that. And again, like I'm not an expert in that field. Like all I know is basically just from reading up lots of research in that area and trying to just like um, kind of entice people in that sphere to look a little bit more on the AI safety domain. And I'm not only saying that Foresight is the only organization that's really looking there. There's a lot of really interesting kind of like work that has been coming out of a few organizations already, but it's still not enough. So I think if I was just pointing to one thing that people could definitely read up on is I think it's called A Tour of Emerging Cryptography Techniques from Ben Garfinkel, or at least that was the previous name of that paper. And he's at GovAI, and the paper can be found there. And it's basically a review of all of the kind of like major cryptographic and auxiliary techniques, and then their application for enabling secure cooperation across humans and AIs. And so that's really, really, really interesting paper. Very long, but it really goes through kind of like those applications in a practical world, in particular for AI. And then there is a lot of really interesting work coming out of Open Mind. Open Mind is basically kind of like an online, mostly like an online course, but also an onboarding vessel and kind of like a journalism vessel with lots of articles being written on kind of like onboarding people into the realm of cryptography. And so it's really interesting. It's a really wonderful project led by Andrew Trask and a few others. And so I think those are like really practical resources that I would point people to if they want to learn much more about this. And I can just like that I can perhaps like riff on a little bit. But I think there's like a few I think different techniques that we could be looking at. So I think first of all, it would be really useful to have these cryptographic and auxiliary techniques to cooperate better across humans. So I already mentioned we're already not super secure in our interactions. So I think even there it would be really wonderful if A, we could secure our interactions, and then B, also use these techniques to enable new cooperative kind of like opportunities that we haven't really explored before. So if we just take human and human cooperation, right, we want computer security so that we at least don't have interactions that we do not want with other people, but we also maybe want to explore and broaden up the space of interactions that we could possibly want, but that we currently can't really get with the law, with the legal systems that we have. So, for example, using privacy preserving technologies, and if that it could be a mix between federated learning or differential privacy. You could perhaps already have much better ways on sharing and kind of like learning from other people's healthcare data, even though it's usually a topic in which usually you are not allowed, right, to share your, or like, let's say physicians are not allowed to share their patients' healthcare data and so forth. But oftentimes, especially for problems like longevity, it would be really useful to actually make sense of kind of like data that other people have collected about their health. But usually, otherwise, you just have an N of one. It's always just me and what a specific intervention does for myself. And that's not just longevity, but it's also rare diseases, right? And oftentimes, it's really difficult in the healthcare sector to learn from other people's data because of the privacy constraints. And if you had things like federated learning or homomorphic encryption or differential privacy, and we're actually able to kind of like use to kind of like basically like use the useful things of someone else's data, and that is also would be useful in your context without actually having to know what the data is, but are able to analyze kind of like the useful kind of like almost metadata or like the useful bits across these data in a way that really preserves the other person's and your privacy. I think you can already kind of like unlock so many new applications and like really great use cases for people. And so that's just for human to human cooperation, right? So there's already a lot of use cases like this in finance and healthcare and so forth that would really benefit from these techniques. But then if we go one step further and look at like human and human cooperation around AI systems, for example, like there's a really great paper from I think it's Emma Blümke, Andrew Trask, Ben Garfinkel, Teddy Collins, and a few others that talks about I think federated, no, what is it called? Selected transparency for regulatory markets or something like that. The paper is called something like that, or at least it was one of the titles that they had on the archive. And it talks about the fact that oftentimes when we think about AI progress and how to kind of like regulate it or um, how to really kind of like make it safe, the only thing that we can come up with is that a nation state or many nation states or like the UN for AI it should kind of like have ultimate control over AI development. That's kind of like as far as we can think. But they are kind of coming up with a privacy preserving protocol for multipolar regulatory markets. And so that basically means that instead of having one actor kind of like be able to look at everyone else's, at every AI lab's data and their models and their weights and being able to enforce a specific enforcement regime on them, instead what you have is you have different actors monitoring each other in a privacy preserving way. And so you have this checks and balances system that is set up using these cryptographic technologies, so that if I'm in AI lab and I'm developing a specific technique, maybe you're in another AI lab developing a different technique, we're coming up with specific kind of like safety metrics that we don't want to go over. We agree on them, and then instead of having the government monitor them, we are monitoring each other, for example. But instead of me actually looking at your model weights, I'm kind of like looking at a kind of like encrypted version of a proof that you're not going above the specific capability that we both agree on. And so through these technologies, you can often have these pretty interesting, more like multipolar checks and balances that don't really kind of require you to actually know all the information that you're using to develop your model, but just the information that I need to know that whatever you're developing doesn't go across a specific safety bar that we both agreed on. And so you can really kind of like be very nitpicky and very precise about the information that you want to share, only in a specific way that I only know as much as I need to know to make sure that we're cooperating in a useful way. And then the final thing I want to mention is for AI systems across each other, or just for an AI system in general, there's also very many interesting kind of cryptographic applications or like auxiliary applications where I think Andrew Trask wrote this paper on homomorphic, what is it? I think it's called Safe AGI, and it's from a while ago. I think it's 2017, and he basically discusses an AI system um, where I think that the is I think two organizations, and you have to look this up. I may be wrong about this, but I think it's different actors cooperating with their data on like basically like two AI building entities are cooperating on a larger kind of like AI power, or like they're basically they're putting both of their problem solving ability together for larger problem solving ability across these different actors. And an interesting thing is not only that they don't really know the individual data that went into that from themselves, but it's also that the AI system doesn't really, it's kind of like the AI system itself doesn't know what the kind of like what the outside data is that it's computing on. And so it is encrypted in a way that you, as the person that is training the AI, you're the key, so that the AI system is kind of like boxed cryptographically, like whatever the data is that it's computing on is kind of like you're still holding the key to any real world applications. And so in that way, like you have this AI system that is perhaps super powerful and can make a lot of sense of the data that you encryptedly giving it, but nevertheless, it doesn't actually know the real world implications of that data onto the world. And so you kind of like having this AI system encryptedly boxed, and so it can't really produce much damage or doesn't really know what the real world implications are of the system that it's computing on. So I think, yeah. Anyway, those are just like a few I think really interesting techniques, and many people are thinking about it like pretty actively right now. I think even the AI executive order that came out yesterday, or like where the bullet points came out yesterday, that mentioned a lot of these pets, like privacy enhancing technologies, and the fact that they're pretty undervalued. So I'm hoping that there's a lot more funding that's coming down the line here. But nevertheless, currently it's still a pretty undervalued area. That was a lot of
It's a lot. It's really good, and I can't help but think. So there's like three kind of layers to it, and the first with the metadata, I can't help but think, that's like such a simple. We can do even without like high tech. We can definitely that's like a low hanging fruit right now, which we could do. We could be kind of sharing data across that's encrypted. We could be trying to tackle. You mentioned health, biotech, longevity kind of questions, but we're still stuck in this like sharing data. And I wonder like is it almost like an idealistic perspective that we have here? And now I know it's a little more philosophical of a question, and probably prodding at your personal views as well. Is it that, yeah, is it realistic to think, or rather, let's not talk about if it's realistic. What is the rate limiting step here, right? Because then the second layer was if we had these mechanisms that allowed, let's say, almost like a security check between AI models. So I'm thinking, I don't know, OpenAI and Convergence, just random two that I could think of, checking themselves and the models that they're developing. But this kind of, it doesn't happen right now. And I wonder, is it because of uh, lack of incentives? If it is, how can we kind of twist those around and really just implement all these concepts that sound like they would have a huge impact both on the safety side, but also in like enhancing huge things like health, innovation in biotech, longevity. I mean, what are your kind of personal views in this as well, or what do you think is kind of stopping this progress?
Well, it's just, I mean, the whole field is like it's still in like early research phases. And I know that, for example, part of I've given a few talks in the last year at crypto conferences, like Web3 conferences, because actually many people that are in Web3, they have a cryptography background and they have a security background. And so my kind of like hunch was that it would be useful to onboard these people more to the AI safety domain. Because many of these people, especially in Web3, they have a pretty good security mindset because, just let's think about like kind of like the ecosystem of um, yeah, of different cryptocurrencies, right? If you kind of like develop one and it's not really secure, it will be taken down very quickly, right? You're creating these like kind of multi-million-dollar bug bounties where if your project isn't secure and it's hacked, often people are able to keep the reward, right? So usually most of the projects that survive for a long time in crypto are in Web3 are the ones that are actually relatively secure because the others just get hacked before. And so I think they have a pretty good like red teaming approach already. And so I was kind of like thinking maybe we can look there and just encourage more people that are already kind of like have grown up or have been encultured into this way of thinking to kind of like move more into the AI safety domain. I think in general, I used to go to these financial cryptography conferences, like I guess um, maybe 9 years. No, that was 9 years ago. It must have been 8 years ago or something when I just came to the Bay Area, and um, they usually focus like pretty strongly on cryptography. Then there's obviously conferences like DEF CON or something where you have like a big security focus. So there are these communities really that are pushing on this, and obviously, cryptography is like a pretty strong academic field as well. But I think in terms of applications, it is pretty complicated. Like even just what I've just tried to explain is like really difficult, and there's like really difficult like technical terms that are just subtly different, and it's not super intuitive. Like things even like zero knowledge proofs take a lot of time to kind of wrap your head around. And so I think it's just not an easy field to explain to policymakers or to explain to people that actually have kind of like that can employ large amounts of funding. And so I feel like that field always often gets overlooked because I feel like cryptographers are also not really kind of like out and about and really like kind of like I don't know evangelizing their discipline. I think from a kind of spirit, like I often feel like they really just like focus on making problem on this one, really really now like the focus making progress on this one really really kind of like yeah, just like hairy problem, like so I don't know, it's a confluence of different factors, but I do think that the entire field is massively underfunded. And of course, like a big problem is also that many of the things, if you actually try to do them, are just economically not really competitive with other ways of doing things, right? So privacy preserving ways, secure ways are always going to be less competitive than if you try to do something not the secure way or not the privacy preserving way. And so oftentimes I think these things just kind of get lost at the wayside because people just decide to do it like the unsecure way, or like they try to like patch a security hole rather than like actually build like secure systems from the ground up, or they're kind of like using some kind of like pretty like standard privacy preserving kind of like technique that is perhaps not really privacy preserving at the end of the day, rather than like actually figuring out what it would mean to like actually do it the correct way, because that is usually more expensive, takes longer, and at that point you're not competitive anymore with any other kind of like company that comes along. And so anyway, it's a multitude of factors I think, but but it just, I think, comes to a point where AI is moving so fast, and it's like it's already like so applicable. It's so kind of like enmeshed in our world. On the other hand, cryptography really isn't. I guess obviously many of the systems that we're using rely on cryptography, but apart from that, not that much. And it could be, I think, it's just like the time lag between where we currently are and I think where we need to be going, and where we currently are in cryptography and where we currently are in AI. I think there's just a lot of difference, and a big delta to bridge.
Yeah. I think I'm gonna second the I think I lost you there for a second. I'm gonna second the socializing security aspect, or at least that's how I refer to it. I think there's a lot of like lack of communication or it being hard to communicate certain concepts, but that's not to say that it isn't communicable. I think we can get to a point where we can help kind of individuals that have the power to make change, be it policymakers, but also actual users, right? At least in the work, at least at the Dahl Center for Future Crime at UCL in London, for example, has multiple research studies where in various fields, so IoT, Internet of Things, and medical devices, where they ran these studies showing different devices to potential users, and the implementation of intervention in the form of like a security label. So something very simple, how to like transfer knowledge of like which device has like better security, and they found that the willingness to pay was actually higher once they were informed, and they understood that the security was better in the device that they were about to purchase, which in my eyes is really promising, right? It means that once we do communicate the benefits of security, it actually triggers or nudges the user to be more willing to purchase that. I mean, we can dig into that because it could also just depend on the device. And then just one more example on the medical devices, just because I mentioned it. I think users would very much want to opt for the more secure device when it comes to things like pacemakers, which they completely leave it up to like doctors or hospitals that have certain procurement policies that actually don't take it into account kind of the information asymmetry, right? They if it passes the medical device regulatory, so if they have FDA approval, they have no idea if like two pacemakers are they assume they're equally secure, which we know is not the case at all. um, so yeah, I completely agree with socializing security, and I think there's a lot more that we can do in this space. One thing that I really wanted to kind of pick your brain, being kind of in the space of like AI safety and really thinking about these concepts, because I personally have the type of threats that I'm thinking about, especially when it comes to AI converging with biotech. But I'd be curious to hear like what are the actual threats, for example, or what are the things that either keep you up at night or the things that you are worried about? Yeah, I try not to be dramatic, but it always like the sentences that come up when you want to ask someone of like what are the threats that you're thinking about are quite dramatic.
Yeah, I mean, I think it's pretty, or I guess the ones that I would mention are perhaps not that unsurprising. I mean, a big one is the security aspect, like just the info security aspect. Let's start maybe there, like in the sense that, I think I already touched on this, but currently I think many of the labs that are developing AI, even though they are actively hiring, um, you know, security researchers that are kind of like really mostly focused on security in that lab, I think they may still not be in a good space to actually defend themselves against hostile nation state actors. So I think there's this interesting book, and I know it's also got a little bit of pushback, but I think nevertheless it investigate like an interesting problem. Like the I think it's from Nicole Perloff, and it's on this is how they determine how the world ends, and it's particularly on 0-day export markets, which apparently were really like kind of like incentivized by the US. So rather than the US, the nation state, or like the let's say the offense oriented nation state, part of the nation state of the US themselves going out and finding 0 days, and let's say like companies that they want to attack. Instead, they really are buying 0-day exploits for target companies on the dark web. And of course, like when the US did that, I think they did that mostly like wanting to kind of like exploit other companies that are perhaps like not located in the United States, but they were also kind of like looking for 0 days of American companies that they could maybe themselves exploit to really like spy on to really spy on like actors that are engaging with US citizens over these through these companies. Anyway, so in a nutshell, there were a lot of like these 0 day markets that the US can like really incentivize by really incentivizing hackers to like find 0 day exploits in many US companies, but also in companies across the world. And since then, these exploits markets have been also pretty well used by China and by like other nation state actors. And so I think at this point, you really have this kind of like machinery and industry, almost like this kind of like yeah, definitely dark web industry across like buying and selling, really like pretty severe security exploits for companies that are holding up much of the US kind of like economic and even like physical infrastructure. And so I think you know with AI systems or with AI becoming more powerful, you definitely kind of like are decreasing the threshold of AI exploits, so that perhaps even script kiddies that usually like find it pretty hard to, I think, establish very elaborate attacks can potentially use kind of like AI generated exploits on companies, but also on individuals. But I think the biggest point is really like nation states that are potentially much more enabled through these export markets to also attack AI producing companies. And so anyway, you have these like double-edged sort of like on the one hand the individual actors like small scale actors become more empowered by AI, but in particular also large scale actors I think become more empowered to also attack AI labs. And I think that is pretty dangerous, I think, on the long run. So that's one, I think, just like info security at AI labs, but also general security at like just across the board. And I think then the second one really is the bio aspect of this. So I think, currently there are a lot of, I think, individual kind of like bio risks, but also perhaps like even, chemical risks that really rely on the fact that not that many people know how to easily pose a very big bio risk on either like a large scale of people or on a very targeted subset of individuals. And it is at least thinkable that with AI enabled technologies, you're much easier able, even as a perhaps like amateur, to develop potentially dangerous weapons, or even just to accidentally develop like very very dangerous um very very dangerous kind of like yeah, really weapons of, I don't know if it's, I would say, of mass destruction, but at least like you are able to do significant damage to biological systems such as us,
Mhm.
and through, I think, the use of AI generated technologies. And I think there was this really interesting podcast that I think FLI had. They had a few, I think, bio biologists on that were using AI systems. That was already a while ago, and they kind of like overnight, or at least in the span of a few days, kind of like rediscovered a lot of the kind of like bio and I think it was either biochemical risks that people were already worried about, plus developed a few potentially new weapon systems, and they were pretty startled at what these AI systems could do, and they were themselves not really quite sure how to handle even that info hazard about talking about these things. And so I think that entire space is definitely something we need to think about, and where I think we really don't really have a good sense yet of how to address it.
Yeah, absolutely. I think you're referring to two things. The one which was, I think it was Kevin Esfelt's like group, like MIT students. It was like a class activity to try and see if they can get ChatGPT 3 to like tell them pathogens that they can either order, and it would like circumvene the DNA screening method and process. And these were MIT students, not all of them kind of bio experts or knew much about biology. And it just shows that you don't need to we've come to a point where you don't need that deep understanding to come up with um I think came up with like 4 sequences and like an hour or so. And this one's a little scarier because the other example that you mentioned, I think, was this pharmaceutical company that kind of came like wrote a public apology in Nature Comms, saying that we've been using AI in drug discovery, and we randomly got invited to a security conference, didn't know why, but just as a, you know, POC, just as a proof of concept, we kind of flipped the parameter that like reduces toxicity and kind of increased toxicity, and they came up with like 40,000 new toxins basically in like 6 hours. Yeah, I also think about like the cyber physical kind of integration. I don't know if you've seen Peter Ney's work from the University of Washington, where he took this concept of like, okay, we've managed to take digital information and store it in physical DNA. And it was like that funny kind of horse GIF. That was like the first thing that they were able to store. And of course, it gave rise to various companies like Catalog, which are working on DNA storage with the hopes of like storing all of our information or archive all of the information in library into like a shoebox worth of DNA, because DNA has this like massive storage capacity, obviously, that it stores all of our information. But he took that concept and said, but hey, okay, well, let's push the boundaries of our like security thinking. Why can't you store malware in the physical DNA so that when it actually gets analyzed in the other end, it compromises the computer and gives remote access to a malicious actor? And to me, that kind of blew my mind. And I wonder, like at this point, I was going to ask you, what are kind of your existential hope scenarios for the threats that you kind of think about? And I'm curious. I think you kind of already mentioned though, like I love the whole multipolar security network thing. I'm gonna definitely be one of the people that's gonna delve into more after this podcast. But I wonder, like, what's your vision for cyber biosecurity, or what are the like existential hope scenarios now, like mapped to these threat scenarios? And if you also think about this like cyber physical issue that keeps me up at night, at least.
Yeah, I mean, it's a really difficult problem because I think I mean, we're just not, we just don't really know what's possible, I think. And so it's really hard to say basically on like how much, even like the open versus closeness. I think Kevin Eswald, who you mentioned, he, I think yesterday, I think like had this kind of like tweet that out on like how a part of like the people in his class were really like kind of like having this hackathon about whether or not like really sharing the weights of a foundation model can negate safeguards further down the road. And they're kind of like imitating very honest bioterrorists, and like we're thinking of like the implications of like sharing model weights openly. And so I think there's always this like very kind of like passionate discussion about open versus closed development of technologies. And honestly, I just don't know how it's going to pan out in these scenarios. Like on the one hand, I think I do have a bias in general to openness. I usually think that especially early on, like I think the more eyes and the more ears and the more hands we can have that are working on specific problems, I think really the more safe we're going to be on the long term. And this is kind of like the notion of like civilization as a problem solving super intelligence that, whenever you have like a small subset of civilization kind of gone rogue and like developing something very dangerous, you can still rely on the rest of the super intelligence of civilization to kind of come together and swarm across this problem and like try to solve it. And I think we've
Here,
seen that
here.
really wonderfully on like many of the problems that even like COVID related, where people came together, like, people like, especially now with this pretty open source scientific ecosystem that like Twitter enabled and whatnot. Like I do feel like the swarming around a problem, like we see very
It's
visibly
true.
these days. Like just like by random people on the internet, just kind of like getting together in bands and like trying to take down a specific scientific concept or something. Even like the superconductivity example, I think is a really great one where like every few minutes, you had new updates. And so I think in general, I do believe in this kind of like open approach to scientific progress is like usually a way to also address risks properly, because more people can kind of like spot potentially dangerous scenarios. And I think Nick Bostrom has this idea. I think it's in the vulnerable world hypothesis, where he kind of discussed technology development and compared the development of technology to kind of drawing balls out of an urn. And you can either draw a white ball, which is like a positive technology, or you can draw a black ball, which is a negative technology. And he basically says that we only kind of like need to draw one very, very negative one to kind of like almost negate the progress that we've been making with all of these white technology balls. And that is kind of like difficult to know when we're drawing one out. And I think it's a little bit more complicated than that. So I think that actually what we're drawing out often are like kind of like grayish balls, like or they're balls that like look one way but then turn out the other way. And I think in order to figure out if a ball is actually like positive or negative or which aspect of a ball are dangerous, I think we need the kind of collective intelligence of civilization to kind of like actually like look at this ball, look at it from different angles, see like if it's shiny or if it's kind of like darkening across how often or like across when you use it. And so it's not as easy as like this is a good technology, this is a bad technology, this one we're going to restrict. But oftentimes you need to kind of use it a bit, and you need to have other people also kind of like monitor it. And I think the less people we have, usually I think monitoring a problem, like the less kind of like the less red teaming we will also get across a problem, right? And so I think in general I do believe that the more eyes on a ball, the easier we're gonna figure out what it is. But I do also totally see the point of the more you open source it, perhaps you let the genie out of the bottle and eventually you can't put it back again. And I think that that is true to some extent. I just don't know if we will be ending up in that scenario anyways, whether or not we're trying to have an open development or not. Because I do think that oftentimes these kind of like dangerous scenarios kind of like they do often happen anyways. And I think they also often happen if you don't have many people vet, and if you don't have many people kind of like just kind of like check that people are using safeguards. And like many of the kind of like I think many of the lab leaks that we often read about, one Toby Ord in his book Precipice goes across like over like a lot of different lab leaks that happen over the course of civilization, where just by sheer kind of like not stupidity but like having your heads in the cloud, we had like some of the most dangerous kind of potential pathogens and so forth leaked from labs that were really secure. So even if you have a strong kind of like even if you're strong closeness or a strong closed mindset, oftentimes if you don't feel like other people are kind of like vetting you and checking you, then I think you can make really really terrible mistakes. So I think ideally what we would have is neither a totally like let loose open development that's just kind of like that's totally open, but you also don't really have a very closed, protected environment where you don't really have any watchers watching the watchers. But instead, you have this kind of like more kind of like very secure cryptography enabled system where different people can kind of like verify and look at what other people are doing, but do so in a privacy preserving way. And that is really hard to do, especially let's say for biology and chemistry, because oftentimes the things that you're working with are such that and you already mentioned, like if you change a tiny specific variant in like in one of these systems, suddenly you get from like a really great drug to like like a pretty powerful like destructive weapon. And so I think the type of monitoring that we're talking about here to actually figure out if one of these things is security enhancing, or if one of these systems is like or if one of these systems is safe and beneficial versus deadly, that type of monitoring that you have to do is like incredible. Like it's absolutely insane. You really need to monitor labs down to like the like a very, very just like absolutely terrifying level of you'd have to have a terrifying level of surveillance, I think, to actually really make sure that things are safe. But like, things like security and A and like other things that like, Kevin Esfeld and that MIT group is working on is I think really trying to make progress in the right directions. And so I think coming up with like ways of like how you can have um, kind of provably secure applications of systems where different individuals or actors or entities or AI systems can check that they're secure, but can do so in a relatively privacy preserving way. If we could have a future that is a little bit more like that, where you have many eyes on the ball, but not totally on the ball, but like maybe in an encrypted way on the ball, then I think I'd feel a little bit more safe. And that's really just the monitoring aspect, right? But then you also have the enforcement aspect, and that's just a totally different beast. I think currently enforcement, is kind of like really dedicated to nation states, and like they are the only ones with kind of like a legitimate use of violence. And I wonder really what the future will look like, in which we may not be able to rely on that anymore. Or in which there's perhaps other enforcement mechanisms that we can think about. But all of this, I think, is pretty dystopian, like which way I look at it. And I just hope that perhaps we can have a few positive technologies that can perhaps outpace some of the risks that we're worried about, and so we get a little bit more slack on that end. But I don't know. It is pretty open. I think it's also pretty ideological, how people think about it, and I think the proof will be in the pudding. We'll just have to tinker and experiment and
Yeah,
figure
but
out like which.
I kind of like
Yeah,
that. I'm stealing the whole white ball, black ball, but can we add more dimensions? Like, what about color and texture? And let's add more to that analogy.
yeah. I want a pink ball. Give me a pink ball, please.
With like scales on it or something. But yeah, well, I think this is the best time to actually talk about it because I think you already do that. So you're doing vision weekends. I think that's one of the many times, but I guess one of like more creative times as well, where you actually do that, right? You present various technologies that are cutting edge, kind of bridged edge, complete edge, like not even spoken about in like common media. And you kind of mix and match. And I think that is a time where you're not only kind of looking at the white and the black or the gray. It's kind of a mixed and beautiful mesh, and I'd love to hear you kind of speak about it. I think, and they're both of them are coming up this year. So again, I'm going to put links on the in the podcast for people that aren't aware of Vision Weekends. But please talk to us about it a little bit, and then we're going to close with my favorite question, which I'll let you know
Oh,
after this.
okay.
Yeah.
Well, I'm strapping my seatbelt on for this final question, but yeah, I think yeah, Vision Weekend is basically our annual member gathering, and it's been happening. I think I already alluded to it at the beginning of the call since really our inception, pretty much. Like we used to have these annual member meetings, and you know, it's basically like has a kind of like totally evolved and avalanched out into two large festivals that we do. One in Europe, in a castle outside of Paris, coming up in 17 days, and then one in December in San Francisco, or like across three iconic Bay Area locations. And one of them is a biolab, one of them is a big kind of like church, and one of them is like a kind of like a private house in the hills. And so we usually pick like pretty kooky, quirky
Yeah.
venues. So sorry, I should say there's also like a rocket lab close to the water in there. So basically, we pick kooky, we pick relatively kooky venues to bring together people working across biotechnology, molecular nanotechnology, neurotechnology, space, AI, and all of these basically our different technical tracks. Everyone who's won a prize that year in our community, everyone who's like really been really great workshop presenters, everyone who's like gotten a grant, all of our fellows, and we basically get together and kind of look at technology progress across different technological domains. And we usually have like a few interactive elements in there, including something like hopefully biosecurity fashion shows or like different aspects that just like can lift people's gaze also across like that are a bit more interactive across like what could be possible with technology development. And those are coming up now, and they're usually, I think, for me, the favorite part of the year because it enables people to really richly collaborate across different technology silos and do so in a really fun, kind of like holiday spirited way. We usually have costume closets and like it's pretty wild, and usually really fun collaborations get out of it. And really big bonds and friendships are forged these weekends. So it's a bit more of a tongue-in-cheek holiday version of some of our technical workshops, but this time bringing everyone together across different technologies. And yeah, it's very good fun. It's a lot of very interesting cats that come and have been coming since a long time now. So it's good fun.
Yeah, absolutely. I like highly recommend it. I think you mentioned it right now. The costume part was actually really fun as well. And you get just like I think it's not only the topics that you get to discuss, but the perspectives. Like everyone's so different. And just the conversations that you get tangled in that weekend is crazy and out of this world. So yeah, highly recommended. Um Now I'd like to, if I haven't lost you, because I think the signal has gone down, Allison, are you still there?
I'm still here. Yeah.
Okay, there you go. The question that I love, it's my favorite one to ask all of my guests, which I say that I help with, but my input is very minimal. It's 2073. I want you to describe our society in 10 words. And some guests kind of like make it into a sentence, others kind of like put 10 words together that kind of paints the picture. It's really up to you. The way I help is literally counting those 10 words with you. So yeah, some support, but not much.
Wow, okay. Well, I don't know if I can actually count these 10 words now, but something like um well, I usually kind of like summarize it as a utopia of utopias in the sense that different people, different people can kind of live their best lives. But you have like a diverse set of these different experiences, all kind of like existing peacefully next to each other and ideally cooperating with each other. I'm not quite sure how I'll make it into 10 words, but maybe I can send you a 10-word
Yeah.
version of that
No, you know
afterwards.
what? I like the utopia of utopias because that's like almost like an Inception way of saying it. You kind of hack the 10 words, right? Just by saying utopia of utopias. I love
Yeah,
that. And it's also a perfect kind of optimistic and positive way to end this podcast. Allison, again, just like with every guest that I bring on, we're scratching the surface. I can speak with you for hours, and I think it's actually endless the amount of things that we can talk about. So maybe we'll invite you up again as a guest if you're up for it.
I
Thank
would
you.
love it. Yeah.
Yeah, thank you so, so much. And we're going to post all the links and kind of direct our audience towards Foresight Institute and all the work that you're involved in. Thank you.
Thank you so much. Have a good one. And I
You
hope to
too.
see you very soon in person. Bye bye.
Yeah, bye.